Hi, my name is Lisbeth Ramos, and today we're going to be going over finding the empirical formula and the molecular formula given this problem right here. So our problem says oxalic acid's composition is 26.7% carbon, 2.2% hydrogen, and 71.1% oxygen by mass. What is the molecular formula if the molecular mass is 90 AMU? So you're probably thinking, how am I supposed to approach this? Right? So the goal is to convert from the grams of a substance to the mole of the substance, divide by the smallest mole, and then get a whole number ratio. However, here, as you can see, there's no grams. But since it says by mass here, we can assume that all of these are going to be out of 100 grams. So that means I can take the 26.7% carbon and turn that into 26.7 grams of carbon. So we're going to take all of these percents, turn them into grams, and then use that to convert to moles. So let's start. First, we're going to start with the carbon. So I have 26.7 grams of carbon. And I'm going to convert that to moles. So since grams is on the top, grams has to be on the bottom so that the units cancel. And I'm going to be left with moles on the top. Whenever you have grams and moles, you can safely assume that it's always going to be 1 mole because molar mass is grams per 1 mole of the substance. So here the molar mass on the periodic table for carbon is 12.011. And when you divide that, you're going to get 2.22 moles of carbon. So that's going to be carbon. Now we're going to go ahead and do hydrogen. So we're going to start off with 2.2 grams of hydrogen. And we're going to convert that to moles. So the molar mass of hydrogen is around 1.01. And that's going to be in 1 mole of hydrogen. And when you divide that out, that's going to give you 2.2 moles of hydrogen. And then the last one we're going to do is going to be oxygen. So you have 71.1 grams of oxygen. And you're going to convert that to moles. Wow, that line was... All right. So then you have 15.9994 grams of oxygen in 1 mole of oxygen, and when you divide that, that gives you around 4.44 moles of oxygen. So now that we have our moles, as you can see, they're not in whole number ratios, but we need them to be. So we're going to divide by the smallest number of moles. So as you can see, hydrogen gave us the smallest number, so we're going to divide by that guy by 2.2. So this will give me approximately 1, this will give me 1, and this will give me 2. So that means that my empirical formula, is going to have 1 carbon, 1 hydrogen, and 2 oxygens. So that's going to be my empirical formula for oxalic acid. However, they're asking us for the molecular formula, and in order to find the molecular formula, we need to find the ratio between the empirical formula mass and the molecular formula mass. So how that equation is going to look like is that we're going to take the molecular formula mass, so I'm just going to write molecular mass, and we're going to divide it by the empirical mass. So in order to find the empirical mass, I'm going to have to add the mass of carbon, which is 12.01, plus hydrogen, which is 1.01, plus oxygen, but times 2. So that'll be around 32. And that mass is going to give me 45.02. So they gave me the molecular mass. Now I have the empirical mass, so now I can find that ratio. My molecular mass is 90 AMU, and this is technically 45.02 AMU. So when you divide 90 by 45, that's going to give you approximately 2. So that means that in relation to the empirical formula, the molecular formula is everything doubled. So the final answer for my molecular formula is going to be my empirical formula times 2. So 1 times 2 is 2. So now I have 2 carbons, 2 hydrogens, and 4 oxygens. And that's going to be the molecular formula of oxalic acid. So to review, when you're doing your empirical formula and molecular formula, to find your empirical formula, you're going to go from grams to moles, divide by the smallest moles that you get from all of your elements, your initial reactants, to get whole number ratios. So let's say this was 1.5 instead of 1, then I would have to multiply everything by 2 to make sure that it's still a whole number. You don't want to have any decimals in there. So once I have the whole number ratio, that's going to give me my empirical formula. Then I have to find the ratio between the molecular mass and the empirical mass, and then whatever ratio you get, you multiply the empirical formula by that, and that'll give you the molecular formula. And that's how you find the molecular formula of a compound.